For page 10, numbers 1 through 10, we're asked to graph some sets. So for these, you need to draw a number line. You could label a whole bunch of numbers on there, or faster would be to label only the numbers you need. That's the technique I'm going to use in this video. Graph the set containing 0 and 1. So somewhere on the number line is the number 0. Mark it, label it 0, and put a dot on that spot. That dot represents the graph of the number 0. Just to the right of that is where 1 is. So you mark it, write 1, and put a dot. These two dots are the graph of 0 and 1. Number 2 we can do in a similar fashion. Here's -1, here's 0, and here's +1. I want to have an equal amount of space between the marks for these numbers. And each of them gets a dot. It's the dot that is the actual graph of the numbers. Number 3, graph set u such that u is any number greater than or equal to -1. The fastest way to graph is to mark where -1 is. Then put a closed dot on that because of the or equal to symbol. Then shade all numbers that are greater than -1. So you shade to the right. And color the arrowhead in when you get there to show that it continues forever. Question 4, graph set y such that y is less than or equal to 3. Mark where 3 is on the line. Put a closed dot on that because of the or equal to part of the symbol. And then shade all numbers less than 3. So you shade this direction. Question 5, graph set e such that e is -2 or +5. So here's -2. To the right of that is where +5 would be located, and each of these gets a dot. Next, number 6, graph set f such that f is 0 or 1. So mark where 0 is, and just to the right of that is where 1 is, and each of these gets a dot. Number 7, graph set p such that p is an integer that's less than 6. Somewhere on the line would be 6. Now this time we don't want to shade because that would shade all numbers on the line, all fractions and decimals. We're restricted to integers. So let's put some marks on there working to the left. Here's 5, here's 4, 3, 2, and so on, forever to the left. P is an integer that's less than 6, so we don't want to put a dot on 6. That's not included in the set. The first integer less than 6 is 5, then 4, then 3, then 2, and so on going to the left forever. Number 8, let's graph set q such that q is an integer that's greater than -2. Well, let's say that that's -2. Then going to the right, the increasing integers are -1, 0, 1, 2, 3, and so on. We don't want to mark -2. The first integer greater than -2 is -1, and then continue to the right. Dot, dot, dot as it continues forever. Number 9, graph the set of numbers x such that x is in between these two numbers. So here's -2, and then to the right of that would be where +4 is. -2 gets a closed dot because x can be equal to -2. But 4 gets an open dot because x must be less than 4. It doesn't have the extra or equal to part of the symbol. X can be any number in between them, so you shade in between those two endpoints. Number 10, graph the set of numbers y such that y is between -1 and 6. Here's -1, somewhere to the right would be +6. These both get closed dots because the symbols have the or equal to parts. And then shade in between. The review assignment takes us back to page 7, number 2. We're asked to solve this equation, and we're given this replacement set for y. If there is a solution, it must come from this set of numbers. 5 subtract 1 is equal to 4, and 5 is in our replacement set, so the answer for y is 5. Number 8, solve for r if r is an integer. Can we find any number that you add 1 to it and you get the same number you started with? No, there's not. The answer is empty set. Number 13 is a true or false question. Let's read this sentence and decide if it sounds true or false. A triangle is not an element of the set containing quadrilaterals. A triangle has 3 sides. Quadrilaterals are 4-sided shapes. The sentence is true. Number 6, we're asked to list out the members of the set. Let's list all members for A such that A is a negative odd integer. The first negative odd integer is -1. And then as you decrease, we would have -3, -5, -7, and so on forever. Next, number 11. Let's list all the elements for x if x has to be an element from this set. Well, x could be 5, or x could be the 6. Number 29 is a matching question. From the second column in the book, what is the correct description of these numbers? The answer is choice C. These are the squares of the integers. 0 is 0 squared. 1 is 1 squared. 4 is 2 squared. 9 is 3 squared, and so on. Number 30. The answer is choice E. These are integers that equal their squares. 0 is equal to the square of 0. 1 is equal to the square of 1. 1 squared is 1. 0 squared is 0. Number 31, the multiples of 4. That would be choice F. Here are some of the multiples of 4. -12, -8, -4, 0, 4, 8, and so on. Number 32, we're looking for the integer that's equal to its double. What integer is the same thing as 2 times that integer? And that answer is 0. 0 is the only number that if you multiply it by 2 to double it, you still get 0. Number 33. This time the answer is choice D. These are non-negative, even integers less than 3. Number 34, the empty set. This matches with choice B, which says integers in between 1/2 and 3/4. There are no integers that come in between those two fractions. Number 35, the number whose sum with 5 is 5. What number can you add to 5 and still get the answer of 5? That number is 0, so choice G again. Last, number 36, we're looking for the negative integer that's between -3/2 and +4. As a decimal, -3/2 is -1.5. Are there any negative integers between that and +4? The answer is choice A. That number is -1.